Let's look at some more of these problems. So this problem says f of x equals x squared inverse tangent x to the third. Now we know that inverse tangent of x is the integration of 1 over 1 plus x squared dx. We know that for certain. And we looked at that in an example in the previous video. And we know that this was the sum. Let's work that out. Let's not go with we know. Let's talk about this 1 over 1 plus x squared. So 1 over 1 plus x squared can be written as 1 over 1 minus negative x squared, which is the summation, or the series, from n equals 0 to infinity of negative x squared to the nth, which is the series from n equals 0 to infinity of negative 1 to the n x to the 2n. So if we fill these terms in, if you put in 0, you have x to the 0, which is 1, minus x squared plus x to the 4th minus x to the 6th plus dot, dot, dot. Oh, and we have the integration and all of this with respect to x. So that, we know all of that. We worked that through before, and we got that the inverse tangent of x equals the integration of the series n equals 0 to infinity of negative 1 to the n x to the 2n with respect to x. And we know that really x is our only variable. So we integrate that to be the sum from n equals 0 to infinity, negative 1 to the n, x to the 2n plus 1 over 2n plus 1. So inverse tangent of x equals this power series. So let's look at the problem given to us. It says f of x equals x squared inverse tangent of x to the third. Now, as we look at this, we're going to use what we have up above. So we're going to say x squared, and then inverse tangent is the series from n equals 0 to infinity, negative 1 to the n. And in place of x, we have x to the third to the 2n plus 1 over 2n plus 1. So we have x squared. We can bring this x squared inside because it doesn't depend upon n, so it can move inside and outside similar to a constant. So we have n equals 0 to infinity, negative 1 to the n. Let's put the x squared right here. And then we have x to the 6n plus 3. We're going to distribute that power. 3 times 2n is 6n, 3 times 1 is 3, all over 2n plus 1. So this is the series from n equals 0 to infinity, negative 1 to the n. Now this, when we multiply these x's, we add the exponents. So we get 6 to the n plus 5 over 2n plus 1. So we have represented it as a power series. Now we have to determine our series of convergence. So we're going to go right here and say we are geometric with the x to the third being repeated. So the absolute value of x to the third is less than 1. X equals plus and minus 1. So our radius of convergence is 1. It's 1 for the original series. We can come back to here. It's 1 for the original series. It's 1 for the final answer. So our radius of convergence is 1. So let's look at another one. It says f of x equals x over 1 plus 4x quantity squared. So let's consider what happens if we have 1 over 1 plus 4x. Well, that means we have 1 over 1 minus negative 4x. So we could write that as a series from n equals 0 to infinity. And we would have negative 4x to the nth power. So that would give us the series from n equals 0 to infinity, negative 1, let's call it, negative 1 to the n, 4 to the n, let's keep it as negative 4. So negative 4 to the nth power, x to the nth power. So we know that 1 over 4 plus x equals everything on the right. So let's take the derivative. We can rewrite this to be 1 plus 4x to the minus 1. Let's look at it that way because the chain rule is easier to see in that case. 1 plus 4x to the minus 1. So the derivative of that is negative 1 plus 4x to the negative 2 times 4, which is negative 4 over 1 plus 4x quantity squared. Now let's differentiate the right-hand side and the right-hand side. So here we have the derivative, differentiation. So the derivative, we start with n equals 1 to infinity, and we have negative 4 to the n, and the derivative of x to the n is n times x to the n minus 1. Now we're going to use what we did before, and we're going to replace n with n plus 1. So that means that we have the sum, instead of n over here, remember that this is n equals 1, so now n plus 1 equals 1, so n equals 0. That's what's happening here. So we have n equals 0. Wrong button. N equals, 0 to infinity. Negative 4 to the n plus 1. N plus 1. X to the n plus 1 minus 1 is just n. So our right-hand side looks like this series. So now let's go back to the problem. It says f of x equals x over 1 plus 4x squared. We're kind of close to that here. So we say f of x equals, the problem is x over 1 plus 4x quantity squared. So this equals what we have, which is negative 4 times 1 plus 4x quantity squared, times, in order to make it look like that, I need to multiply by x over negative 4. So let's switch those. Commutative property. So we have x over negative 4 times negative 4 over 1 plus 4x quantity squared. Now we know that this series equals, this fraction equals the series above. So we have x over negative 4 times the series from n equals 0 to infinity, negative 4 to the n plus 1 times n plus 1 times x to the n. So let's bring the fraction out front inside the summation. So we have from n equals 0 to infinity, we have x over negative 4 times negative 4 to the n plus 1, n plus 1, x to the n. Let's simplify. So we go from n equals 0 to infinity. Now we have these negative 4s. We have negative 4 to the n plus 1 over negative 4, so that just gives us negative 4 to the n. We have n plus 1 here, and x to the n plus 1 is x to the n plus 1. At this point, let's write it one more time. N equals 0 to infinity. Let's pull out the negative 1 to the n, 4 to the n, n plus 1, x to the n plus 1. So that's our power series. Now let's talk about our radius of convergence. Let's go back up to right here. Back to here. If we go back to here, we see that r equals negative 4x. And it's a geometric series. So let's, to talk about our radius of convergence, let's say the absolute value of negative 4x is less than 1. So this means the absolute value of 4x is less than 1. So that tells us that you could divide by 4 because it's a constant. 4 times the absolute value of x is less than 1. So the absolute value of x is less than 1/4. So our radius of convergence is 1/4. So up here we have our power series representation with the radius of convergence of 1/4 because the radius of convergence is maintained. So let's look at another example. Let's look at the problem, and it says f of x equals natural log of 5 minus x. So if you look at this one, we know that the derivative of the natural log of 5 over x, d over dx of natural log of x, of natural log of x is 1 over x. So the derivative of natural log of 5 minus x would be 1 over 5 minus x times negative 1, which is negative 1 over 5 minus x, using our chain rule. So in order to work with this, what we need to do is we need to work with the antiderivative like we did in the inverse tangent area. So we're going to say that the natural log of 5 minus x equals the integration of 1 over 5 minus x negative with respect to x. So just as we did before, let's change the right-hand side to a power series. So we're going to use the commutative property of addition and switch these. Actually, we have the 5 where we need it. So let's just, and we have the minus, so let's just factor out the 5 and say 1 minus x over 5 dx. So this means I have negative 1/5 integration of 1 over 1 minus x over 5 dx. Well, that slides into our power series very well. So we have negative 1/5 and then the integration of the series from n equals 0 to infinity of x over 5 to the nth power dx. So let's rewrite that. So we have negative 1/5 times the integration of n equals 0 to infinity. And then we have x to the 5th over, sorry, not x to the 5th, x to the nth, x to the n over 5 to the n dx. So now we can integrate. When we integrate, remember we have a plus c. So in the series, those come first. And then instead of a plus, we have minus 1/5. And then the series from n equals 0 to infinity. Now the 5 to the n power is a constant, so we're going to leave it down here. So when we integrate x to n, we get x to the n plus 1. And we divide by the new power of n plus 1. So now we need to bring our negative 1/5 inside. Now the negative can stay because there's only one of them. So we have n equals 0 to infinity. By only one of them, I mean that it's not negative 1 to the nth power. There's only one negative. We're going to subtract everything. We keep x to the n plus 1 on top. In the denominator, we have 5 to the n times 5 to the first. That makes 5 to the n plus 1. And then we say n plus 1 down here. Now, notice that everything is in terms of n plus 1. So we're going to replace n plus 1 with n, which is the opposite of what we did before. So before we had n equals 0. And so this becomes n equals 1 because n minus 1, well, I guess that's the way it goes. N minus 1 equals 0. So n equals 1. So we end up with c minus the sum from n equals 1 to infinity. You have to start at 1 because we're replacing all of those x to the n over n times 5 to the n. So if we put in x equals 0, on this side we have the natural log of 5 minus x. So if we put x equals 0, we get the natural log of 5 equals c minus x is 0, so all of that is 0. So we find that c is the natural log of 5. So then we have the natural log of 5 minus x equals the natural log of 5 minus the series from n equals 1 to infinity. We have x to the n over n times 5 to the n. Now we need to go back and get our series of convergence. So let's go back up to the top up here. At one point we talked about it, I thought. So when you look at what we put into our power series, right here, our power series, this is a geometric series. So I put absolute value. Since it's geometric, r equals x over 5. So this means that our convergence is the absolute value of x over 5. So we say the absolute value of x is less than 5. So our radius of convergence is 5 for the power series. So down here, our radius of convergence is still 5. I think that should help you. If you have any questions, let me know. I can always add to it or work through one of them with you. Have a great day. Thanks.